of the questions that they asked. What does this ball do? Can somebody in a sentence just describe what the ball does? We've got two people with their hands up. Go ahead, you're right here in the front.
It goes up the ramp and then it goes back down the ramp.
Goes up the ramp and comes back down the ramp. So it's not particularly hard to kind of conceptualize what's happening here, right? So Adi, my question for you then is, when I ask how far it goes, what's the connotation of that question?
Where they go up the ramp,
I think that's the connotation. So if you guys don't understand what I mean by that, especially you guys at home, when you're asked how far it goes, I am looking for distance, not displacement. So you should be looking for the distance. We have a method for doing that, but it involves us, if you don't remember, kind of plotting out what was happening. Something like that, where we figure out the areas. And once we figure out these areas, we make sure we turn them all positive, because that'll give us the distance. But I don't want to do that. The goal here is not to graph this. The goal here is to see if you can find a way to take what you've been given and use that information to figure out what's being asked. That's what these questions are about. And that doesn't mean that they're easy, but it also suggests that there's probably some trick that you can impose that'll make this something easier to deal with. So, let me get all that out of the way and restart it. So again, I have the ball going up the ramp. It takes 15 seconds to come back down. I would start, if I were you, by considering what information you could glean from the problem that is useful. Somebody at home offer me an idea of something that we could use here that's useful. And by the way, there's more than one way to do this problem. All right, I'll just pick somebody. Cassie, can you give me a piece of information that's useful here?
Well, it has an initial velocity of 5 meters per second.
I think that's something that we can use that is useful. Now, while I'm going through this question, I'm going to encourage you to consider a series of steps that can help you solve these problems, even if you don't fully appreciate or understand what we're doing. So, and if you don't understand those statements, let me translate this. If you are lazy and don't want to learn that much, these steps will help you. First, be aware I give all of the units every time. I have to. So when you're looking at the information that's given, it has to match up with those units. Don't be the person who puts something that has the wrong units in the wrong place here. If you say that its initial velocity is 5 seconds, you're going to look like an idiot. And we're trying to avoid that as much as possible. So you'll be given the units. That should pretty much stratify where things go. Next, and this one is not easy. These are vector values. They have direction. The problem is not going to give you direction. You have to decide what direction you're going to call positive. Decide at the beginning of the question. Trust me, your very next example is going to put this into a difficult place for you. So decide at the beginning. Now, we have more information to bear here, but I don't think it's obvious what you should do. I think it's going to take you guys thinking it through. Can somebody offer something they think we could do to figure out how far the ball went? Go ahead.
You could calculate the distance of the ball towards the top of the ramp.
We could do that. We could calculate the distance it goes when it travels to the top of the ramp, or at least to where how do we know it's reached its highest point? There it is. we can find out how far it goes when it comes to rest. That's a good idea. But we will need another piece of information. These can only be solved when we have 3 pieces of information. Is there something else we can use here that we haven't used yet? Yes, ma'am. Does it take 15 seconds to come to rest? I think that's not unreasonable, that it would take half the time to go up the ramp and the other half of the time to come down the ramp. That seems like a reasonable assumption. This is the physics of the question, folks. You guys making these kinds of assumptions and recognizing how the world works is what I'm looking for on your test. You can plug numbers into an equation. I'm not worried about that, and you don't get much credit for that. If this problem is worth 10 points, 5 of the points would be you assessing the question and coming up with a reasonable way to solve it. 2 of the points will be plugging it into the equation and getting a numerical answer. So when you consider how I'm going to give you points on a test, you coming up with a method to solve the problem is worth by far the most credit. Now, getting back to my set of steps, we have identified 3 pieces of information. It's appropriate that once we've identified the 3 pieces of information, that we identify what has been asked for and what is unnecessary. For example, we have been asked to figure out how far the ball goes. The acceleration wasn't given, and it's unnecessary because we're not being asked about it. This will help dictate how to solve the problem. Yesterday, I gave you 5 relationships, and you have to have them memorized by when? That's right, next week, Monday. At the rate first period's going, it's probably going to be Tuesday. But we'll see how you guys are doing. I'm rewriting them right now because some people didn't bother to write them down yesterday, much to my disappointment. I assume you have a note card with all of them on it right now, sitting next to you or close to you. If it were me, I would also have something else labeled next to them. You see, I labeled them with the variable that is missing off to the left. If you want a procedure to do this that doesn't make you have to think very much, then all you need to do is identify the variable that wasn't given and is unnecessary. Because that will tell you which relationship will give you the answer the quickest. We have 3 pieces of information. We are looking for a 4th. So I'm going to use the relationship that doesn't have acceleration in it. We weren't given the acceleration. It's not necessary to the problem. So everything should fit in this relationship, and there should be one missing variable, and it should be the one I'm looking for. So once I recognize that, I'm going to start with that relationship. So not a space, and won't let me move just that, so I'm just going to erase it, rewrite it. So delta x equals 1/2. The initial velocity is 5, the final velocity is 0, times the time of 7.5 seconds. And there you go. That's it. I don't care what the answer is. By the way, this will not give you the answer. And only if you're really paying attention do you know why that won't give you the answer. Can somebody at home tell us why that's not going to be the answer?
It's not the first time.
Well, that's not exactly the answer I was looking for, but that is true. We were asked for how far the ball went. Will this be how far the ball goes? Now, how much of this, or how much of the trip is this?
the trip.
Half the trip. So whatever you get here, you will probably have to double it to get the entire trip. Again, I have a building that is 10 meters tall. You are standing at the bottom of the building, and your friend is at the top. You are going to throw a ball upwards at 25 meters per second. Now, I need to tell you this, and it's something that you should probably put in your notes, big and bold someplace, highlight, put a box around it, whatever you do to identify something that's important. The acceleration due to gravity near the surface of the Earth is always 9.8 meters per second squared directed downwards. Meaning gravity accelerates all objects downwards at 9.8 meters per second squared near the surface of the Earth. I'm being very careful because that's not true anywhere else, just near the surface of the Earth. On mastering, you have to use 9.8. In class, we use 10. And on the AP exam, we use 10. But mastering requires 9.8 because they're so exact. But 10 is just easier. So we'll use 10. So gravity is acting downwards, 10 meters per second all the time. You throw the ball upwards, 25 meters per second. Your friend is standing above you, 10 meters high. When does the ball pass your friend? That's the question. I'm going to give you guys about 2, maybe 3 minutes. There's a reason this one's harder than the last one. So 2, maybe 3 minutes. You guys at home, I'm going to send you in a room so you can talk with somebody, or you can mutually sleep, whatever it is you guys do when I send you into your breakout rooms. Judging by the looks on everybody's faces, I'm thinking sleeping is in order. But in here, we'll talk. So there you go. I'll jump into your rooms in a little bit. You guys go talk to somebody. I will be calling on at least one person at home and one person here in the classroom. The car starts from rest, accelerates at 5 meters per second squared for 5 seconds, then immediately slams on the brakes and comes to rest. How far did the car go? I want the total displacement of the car. Same level of difficulty, just a different wrinkle. I'll give 2 hints though. There's 2 accelerations given, but you can only use one at a time. And the second hint, be careful about direction. All right. This time, I am planning on asking a person or two to step me through what they would do for this question. I'm going to be less willing to direct you. So I'm going to fire up some volunteers. In the participant window, do you want to go back into breakout rooms or not? Give me a yes or a no. They're going to talk here. All right. Three minutes. There is a trick here. If you think triggers. Okay. Maybe they're triggers. You can only use one acceleration at a time, which suggests that there's two problems here, not one. How do you feel like you're stuck? It's okay to be stuck. I'm only going to start in a few minutes. All right, I'll bring these guys back from the breakout rooms. But what I'll tell you is You actually have two problems here, not one. Let's get these guys back. How'd you guys at home do? Well, once I came back quick, they must have known what they were doing. The ones who were still in the breakout rooms, probably not so much. So, did you make to the right positive or to the left positive? All right, you have to choose. Doesn't matter to me which one we choose, but if we choose to the right positive, that makes a significant statement for us. First, I don't really know how far the car went in either one of these, but I can only do one acceleration at a time. So there's a time when the car was getting faster. It started from rest and accelerated for 5 seconds. That's 3 pieces of information right there. It doesn't tell me how far the car traveled for the whole thing, but it would tell me how far the car traveled while it was speeding up. Now, when it's slowing down, I know its final velocity is 0. And I know the acceleration is 7 meters per second squared. But I don't have any other information that was given to me that I can use during the second part.
Would the 7 meters per second squared be negative?
Excellent. I'm glad somebody pointed that out. Thank you very much. Now, you might not have known that you needed to break this up into 2 parts like this. A few of you in the classroom did probably figure this out, and I'm hoping a few people at home did as well. What can you use that will bring these 2 parts together? There's some intuition here. Who can tell me what it is? Anybody at home have an idea?
The velocities?
What do you mean, the velocities?
Well, if you can find the final velocity of the 5 meters per second squared one, you can find the final velocity there, and then you connect the final velocity there and place it where the initial velocity is for the negative 7 meters per second.
That's the trick. That's exactly right. That's the trick. Once you understand that that's the trick, the rest of it's just plugging numbers in. But you're right. The car accelerates for 5 seconds and reaches a speed of what, 25 meters per second? Use one of the motion equations. You can figure that out. But that becomes the initial velocity when he hits the brakes. Now you have a variety of things. You can figure out how far he goes when he's speeding up and how far he goes when he's slowing down. These problems aren't terrible, but they do take some getting used to. And sometimes they take, a little bit of patience. Now, there are harder questions than this. But when it comes to the physics part, again, I don't really care what the answer is. The answer is nice because I can just look at that number and know whether you did it right or wrong. It's understanding that you can figure out how to organize yourself and what to do with the information that's given that's actually worth the points. So yes, I do expect you to go the extra mile here and to plug it all in and get the numbers, but I don't care what they are. I don't want to spend time on that. We have 12 minutes left, but that's a little bit of homeroom time. My preference is for us to at least see one more example, because I had 4 planned, but how many of you feel like you're getting more confident here? You guys in the room, if you feel more confident, just put your hand up. You guys at home, same kind of idea. Are you getting more confident? Okay, what I'd prefer to do then is let you guys do the work and me kind of circulate and help people out. So you have that worksheet that has a bunch of just simple, straightforward practice questions. It has little graphs on it. If you don't want a graph, that's fine. I don't care about the graphs. I care about you figuring out how to solve it. The first page is probably the easier side. The second page has a few more that are difficult. If you're doing great at it, start on the second page. If you're not doing so good, start on the first page. Now, you guys that are here in the classroom, I'm going to circulate and I'll come one-on-one and help you guys out. You guys who are at home, I'll be happy to answer questions one-on-one as well. Okay? All right, so I'm going to change some things around here for just a minute. And you guys here at home, I'll be right back. If you have specific questions, I'll be back in about 2 minutes to answer them. I'm going to walk the room a minute and turn my lights on. Looking it up on Canvas. If you had it done, I was going to take a look at your work. All right, folks, are there any questions over here? Anybody needs some pointers? How many of you made an attempt at it already? Okay, are there any, do you want me to check it? Do you want me to look at what you did? I mean, you could have looked them up on the internet, they're out there. But hopefully some of you tried them on your own. If you want me to see what you did, you'll just need to hold it up and I can just make your window big for me to see. Uh-huh. Okay. What's something you want me to see here? Nobody. Okay.
Actually, yeah, for me.
Okay.
Number 5 on the back, the second page.
Can you show me
I
real?
was just
What does it say? Oh, there it is. Yeah, just hold it up real quick. Okay, and slide it to the left so I can see the problem. Okay. Okay, go ahead.
okay, so I was just making sure that I was doing the second part right because it said determine the distance it travels in the 3rd second. So I was thinking, take the